Hello, my friend. Haven't seen you guys for a while. My name is Nathan, a front-end developer from Melbourne. Yeah, today is a beautiful day outside. I should have go out rather than recording here. But the topics today are gonna be very interesting, which is also fundamental. We're going to talk about asynchronous programming with both C# and JavaScript. Right, asynchronous programming with JavaScript and C#. Imagine you are running a restaurant and you have 5 cooks, a waiter who is a Superman, which means he delivers in lightning speed. And you have countless tables where those orders are from. You can imagine those are requests. So if you are running this restaurant, how normally would you run it? A typical mindset is you will distribute all those incoming orders evenly to the 5 cooks so they can work in parallel. Anyone who finished the dishes, and they'll be ready, and the cook will tap the bell, and the waiter will deliver the corresponding dishes to the table, to the customer. It's as simple as that. So keep that in mind. There's not much difference how asynchronous programming works for Node.js and .NET. So for JavaScript, if you have a file of a JavaScript program and it's executed from top to down, and when it comes to high cost functions, that will be delivered to web API for the browser. If it's Node.js, that'll be C or C++. Once those are done, you can imagine a dish has been cooked and is ready for deliver. The corresponding function will be put back to a queue, and the node event loop will push that back to the call stack and consume it afterwards. This is how JavaScript works, always non-blocking and event loop. Right, keep that in mind. Let's see some examples. Just to elaborate the concept clear, I'm using an example with the React.js in the front end and the Node.js in the back end. So when the home page is loading, after the rendering, it will go into use effect function, lifecycle function. I deliberately typing out the sequence from top to down and see what happens. So if we are refreshing the page, what you can see actually, it will run console log 1 first, and when it goes to the promise, JavaScript will deliver the promise to web API and keep the current thread non-blocking. So the second line will be run should be console log 3. After the JavaScript successfully fetch the to-do list from the backend, it comes back and typing out number 2 and set corresponding states which will re-render the UI. That's why you can see the list here. So that's the basic concept. So let's look at the get list items method. We are using Axios here to do API calls and fetching the to-do list. What it returns is a promise. So basically, you can imagine if we make this as mock data, what it does is it returns, say, a promise with the resolve and the other method. You can rename it in whatever way. We reject, right? And from inside the promise, you can define the resolve method returns like a to-do list, which is an array of things to do, right? And the reject method is where you define the errors. You can define an error with the corresponding message. just error. Right, quite simple. So with that promise, and the reject value, the resolve value will appear in the then bracket, and the value in reject method will appear in the catch block. So then let's come back to the home page. Inside the then bracket, this should be resolved value, and the error should be the reject value. Very straightforward. Remove the mock data and revert it back to Axios. Then go back to the home page, remove all the console log stuff. And now we are trying another way of consuming JavaScript promise, which is async await. Let's comment it out, and let's do this. Since get list items returns a promise here, so we can use to-do list await get list items. But anyway, we are using await, we need to define the function as async. Let's refresh the page, see if that works. Yeah, that's still working. Just as a kind of reminder, if you are using Babel, you need to define the target with the node 10 plus. All right, this is a JavaScript. We just introduced the two ways of doing asynchronous programming. One is using promise, the other one is using async await, which makes sense. Now, when it goes to .NET environment, there are more details to talk about, even though they are similar. I would like to mention two sides of story. Normally, we understand if we are using await and async, the main thread will not be blocked and keep going. That's the main purpose. But another side of story is about the thread pool. When the request comes in, it will be assigned with a dedicated thread. That's the main thread. And when it comes to when it comes to the line await and get an asynchronous function, it will go into another thread. So another thread is borrowed from the thread pool. You can name it thread 2, which go down and turn to HTTP client, which is system.net HTTP library, and talk to the operating system. The operating system will find the corresponding driver, could be either a network driver or database query, a database driver or a hard disk driver. And if a task cannot be done immediately, the driver will know, hey, I need to return a pending to the operating system. The operating system will return the pending to systemnet.http library and all the way up to .NET container. So when .NET container receives the pending status, they know, hey, it's time to release this thread 2. Just to show you what I mean, I built a simple MVC website with the C#.NET core, and basically it does a very simple thing for the home controller. It calls the backend and fetching some dummy data, which is a to-do list. And I'm using a HTTP client, which is using system.net HTTP library. So this is async action, and when it comes to 908, it will go into a different thread, and so the current main thread can continue going. Imagine you have a heavy calculation later afterwards, then you can do it here. That won't be blocked. That's the benefit. But the cost is it did actually borrowed another thread from the thread pool. So as you can see, it's calling get string async method, which is asynchronous method. Basically, it will talk to the operating system, and operating system will talk to I/O all the way down and up. It will return pending status. That's what it means. If it doesn't, the consequence will be it will block this thread. But the benefit is it will keep the current main string ongoing. But if you are using CQRS pattern, having a mediator, for example, here you are borrowing more than just one thread, but multiple thread. Just to show you what I mean, so from here 935, actually that goes to thread 2, and in the corresponding handler of CQRS, it will borrow another thread. Imagine this is not an async function by default, but it is a synchronous function. Humanity made it async by wrapping it with task.run. The consequence will be it will block at least this thread and this thread. So 2 more threads are borrowed from the thread pool and they are blocked. The main thread definitely is continuous going without block, but at what cost? The cost is 2 more threads borrowed from the thread pool are blocked. So in this scenario, you might need to balance a little bit. So to sum up, asynchronous programming is great, but if you don't use it smartly, it will cost more. Ideally, for those accesses to the network, to database, or to the hard disk, they need to be implemented as async in the low level. If it doesn't, you manually put it into task.run and wrap it, even though it makes it looks like async, but that's at a cost of blocking multiple threads. You need to make a balance, whether that's worthy or not. If it is an HTTP call might take a half second, it might be worthy. You wrap it with task.run and cost a few more threads. But if it is just a comparatively complex calculation and you want to put in different threads, I would not suggest you do so. Yeah, because the cost is higher than the time you saved. Overall, the JavaScript or C#, they are similar in terms of handling asynchronous programming. The main purpose is to keep things ongoing and non-blocking. Yeah, hope this lesson can bring you better understanding of asynchronous programming and avoid some common mistakes in the future.